All right, well, thank you everyone for joining us within the rain. Is that? Oh yeah, so, okay, thank you everyone for joining us in the rain, and I appreciate you coming out and getting wet. We'll keep this short as introduction since we're already 10 minutes late, as you see the technical difficulties. Some fun facts about Dr. David Quarfoot. He finished his PhD here at the joint SDSU-UCSD program in Mathematics and Science Education, so he's one of our own. He's an associate teaching professor in the Department of Mathematics at UCSD. A couple of things that are fun facts about David is that he plays 3 instruments. He plays the violin, the viola, and the cello, is that right? And he has written over 40 crossword puzzles for the New York Times, which is really brainiac. So, without further ado, please welcome David Quarfoot.
Well, thank you, Chris. I really appreciate that introduction. As you mentioned, my name is David Quarfoot. I'm an associate teaching professor at UCSD. I teach half math and half statistics. I've been there for about 7 years now. So thank you for inviting me to this and scheduling this in a fairly large room. I wouldn't know what to do if I were in a small room, because that's not my life anymore. So let me start by giving you a sense of what we're going to do today. I'm going to try to make this interactive to some degree, and you can see some of the things that I do in my classes. In order to do that, it's helpful if you can log in to this site, socratic.com. You can do this on your cell phone or on your computer, and you can use this top idea here of my last name, Quarfoot in all caps, as the room name. And as you're getting that going here, I'll give you a little background on me. So I started teaching about 20 years ago at Choate Rosemary Hall. This is a private high school in Connecticut, and my class sizes were about 5 to 15. I taught 4 classes at a time, so I had about 50 students per year with whom I worked, because I tended to keep the same students from one semester to the next. After that, I headed off to University of Utah to get my master's in pure math, and there I was the instructor of record for some larger class sizes. Now we've made it up to 30 to 60, but a long way from where I am now. After getting that master's, I went back to the Roxbury Latin School. This was a school on the East Coast. It's a private all-boys day school, middle school, high school, and again, I was teaching these small classes 5 to 15. So about 50 students a year with whom I would have some really deep connection. And in my current job at UCSD, which started in 2016, you can see the class sizes are much bigger. Now we've made it up to 80 to 400 is my typical class size per course, and I teach about 6 classes per year. So you might have noticed that these numbers are getting bigger in my life. I'm teaching larger and larger things, and you can see here on the right side, this is the historical trend of what's happened at UCSD. The school started in the 1960s, and in those 60s, when it first began, UCSD only had a very small number of people. It began with 100 people, roughly, all graduate students. And then as you go through down the years on the right side, you see it getting bigger to about 30,000 in 2015, and the current enrollment of about 42,000 undergrads and grads combined. That's quite a dramatic growth in just 60 years for a very young school. Now with that has come very large class sizes, as you might expect. So here are some of my recent class sizes. I didn't cherry pick these are just things I've been doing lately, and you can see they're pretty big. And they're also quite indicative of what's going on at the lower division level. Doesn't matter if you're taking pre-calculus or STEM Calc 2, there are big numbers, even all the way up to linear algebra, where we have a class of size 500 this quarter. Now, when you teach for 7 years in this environment, you pick up a few things on the fly, and I want to go through some of these lessons today. So the first thing is, you have to have some policies in place to push back on the administrative force, the wave that's coming at you. So since I do a bunch of statistics, I'll frame some of these things statistically, so it feels a little more mathematical today. So we'll start with a random student, probability P, that they're going to miss some deadline. That might be a homework that's submitted, it might be showing up for an exam, something like that. Now if you want to expand this out to your whole class, now we can create a binomial distribution. which is something that helps model when you have n people instead of just one. And we can let x be the number of students in your class that are going to have some problem meeting some deadline. Now, for those that know statistical theory, you know on average, what the expected value is n times p, which is also intuitive. So what I want to first explore is what's going to happen in the expression n times p when you look at some different n's and p's. So if you're lucky enough to have a class of size 25, and we'll set p as, oh, only a 5% chance. I'll be very generous right now. You'll see that you're going to wake up the next day after your event and have an email about one. And almost any teacher could manage this, right? Now, as you push this up to size 200, now you wake up to 10 emails the next day. And if you want some more realistic numbers, we'll go to my class in the fall. I taught 450 students, and we have a 7% value for P now. And you can see that I would wake up to 32 emails every single day if I didn't do what we're about to talk about. And this is just for one event, one homework assignment, one exam, one class that people are getting sick and can't come to. So when you multiply by the number of events in the course, you see the administrative wave that's going to come crashing down. So here's some of the flexible policies that I use. First of all, I always have a drop X of Y homework assignments, maybe 2 out of 17 or 1 out of 15, something like that. I do the same thing if I'm going to have attendance checks in a class, 7 out of 10, 8 out of 10 are all that you have to come to. I can drop 2 for you. And now when people can't come to something, you don't get an email. People just say, okay, I guess I'm part of that drop 2. They take that, and it reduces the administrative wave. Also, if you podcast things, people just watch the podcast, and you don't need an email sent to you. Now, a lot of emails you get are about tech reasons, especially if you're going to be uploading homework to online systems and such. So I always built in a guaranteed tech window to what I'm doing. So the homework's really due at 9, but you can have 2 more hours for tech issues. And hence, you can never send an email about tech issues because there's a whole window devoted to them. I also do this with exams, something I never thought I would do. But it actually turns out really well. So you might have Formula 1 here, which is your typical grading formula in many college classes with 2 midterms and a final. But you can have an alternative Formula 2, where you say, okay, we're going to drop your lowest exam score, take your better one, and that missing thing that we just got rid of will make your final exam worth more, effectively replacing your worst exam score with the final. Now, this is incredibly useful. It means you never have to go write a makeup exam, and I never have in 7 years. It's simply not possible to create a new exam for every situation when it takes 10 hours to carefully write an exam, proof it, run it through all of your TAs to make sure that it's accessible to all students and that there's nothing unfair about it. It's just not possible. Now, you might worry that these kinds of policies cause big trouble and inflate grades. So, here's some actual data from 207 of my students in one of my classes. You can see how they do on Formula 1 on the horizontal axis, Formula 2 on the vertical, and the line y equals x would be them doing equally well on both. They tend to cluster around y equals x or something quite close to it. If anything, it just inflates it a tiny bit. People tend to do quite consistently across everything in a class, is my experience. Now, this is the first time we're going to get interactive here. We're going to pull out Socrative now. And we're probably going to break the internet by trying this. So let's see if we can come up with some of the policies you use to reduce the administrative workload in a class. Give me what you got here. People in Zoom, if you could just type right now. Again, you're going to come up with something that reduces administrative workload. You can type it in the chat window. Chris, do you want to monitor chat? Chris? Monitor chat. Is that something?
DQ, are you sharing that screen up there?
Chris, you can do it.
Okay.
Okay. So Mike's going to monitor the chat.
Thank you.
questions as they come, or do you want to? Sorry, do you want questions as they come? Or did you want questions as they come, or were you giving people?
Oh, I'll come to you.
I've got one so far.
Hi, we're going to start in chat. Mike McKean's going to help us there. What have you seen from chat?
I just have from Sherry asked everyone having FAQs about your class.
Having what?
FAQs.
Very good idea. Having an FAQ section in the syllabus. That's very nice. Let's see what we got here now that we reveal this. Take-home exams, collecting work over grade scope. Google form to request homework extensions. Interesting idea. So you can take a screenshot or a camera picture if you want to see these. No homework. That's an interesting idea. I'm actually considering that idea in future quarters. Hi, let's move on to the second lesson here, and it's about rare and ultra rare events. So I'm going to do a little more modeling with stats here. We'll take lambda as a rate at which these things happen. We'll start with a rare event, and we'll say a rare event is something for a student that happens 1 out of 100 days. Okay, so there's some definition you could make. Now the first thing you want to do is scale up that rate to an entire class. So if you have 300 people, say, it's pretty big, and you have a 70-day quarter, you might wonder how many rare events you're going to see. 210 rare events, or roughly 21 per week in a 10-week quarter. Now that's just an average rate. If you use a Poisson distribution, you can see the different possibilities on the horizontal axis and how likely they are on the vertical axis. And you'll notice that everything from about 160 to 260 is quite common in this scenario. You can see some examples here of some rare events that I get often. Submitting the wrong homework, for example. Now, I actually think it's more interesting to think about the ultra rare events. So I say this is 1 out of 1,000 days a student will experience an ultra rare event. So that is once every 3 calendar years, or once every 1 college career, you have an ultra rare event. Okay? So scale that up, and now you have 21 of these per quarter in a given class. Now, I have some examples down here of things that happened this quarter to me. I do consider these pretty ultra rare. A student sent me an email with a picture of a car that had driven into the apartment and broke the wall. Okay, there's something that happened. You can see other examples here. The reason I bring this up is not only to make you aware of the mathematical reality that you're going to face in a large lecture class, but perhaps more importantly, you have to develop a patience with these things. If you're teaching in a normal teaching setting with small classes, you see an ultra rare thing maybe once every 3 or 4 years. So you've had this time to emotionally adapt. You get worked up over it, and then you deal with it, and then time goes on. But when they come once a week, you have to have the patience to deal with that. Because for the student, it's their 1 in a college career event. For you, it's something that you see 21 times a quarter. And I think that difference, you have to make sure you deal with it properly. Okay, here's another one. There's little hope of a shared knowledge base. So again, we'll take this at the student level start. P is the probability a random student is familiar with your exotic context that you were so excited about. You wanted a problem about baseball. So you put a problem about baseball. So I want you to think for a moment. So first, your turn. If you have a class of size n, what's the probability all the students will be familiar with your context? So I'll give you a minute to think about this.
I think the answer is 0.
Does anyone in the room want to share out their guess here?
Extremely low.
Less than 1%.
25%.
Well, the answer should involve P,
P.
and it should involve N.
1 minus p to the n.
1 minus.
Oh, p to the n.
Let's figure it out. So first, we'll set S sub I as an event that student I knows what you're talking about. So that's n different events I just defined. If you want everyone to know about it, it's just S1 knowing about it, and then the next person knowing about it, and so on. And in probability, all those ands are going to turn into products if they're independent events. And then each of these is just p, given p to the n. Now, it doesn't help when it's written as p to the n. It helps to think about it with certain values of p and certain class sizes. So let's start very generously. You're clever enough to pick up something that's 90% people know about. 9 out of 10 students know. You're trying to choose something that you think is familiar. Well, in your class size of 15, there's only a 20% chance all of them have heard about it. And you can see by the time we get up to 50 or 200 students, you've basically reached a 0% probability. How's that for reality? Here are some of my failed settings that I thought for sure everyone would know about. An American deck of cards? No way, not in a highly international school like UCSD. Baseball, this quarter, a student said, I've never seen the game of baseball and I don't know this thing called a home run you're referring to. Actually happened. I've tried mathematical settings, like the word divisibility and prime numbers. Nope, those fail too. I've even tried cardinal directions and hiking. I had students say I don't know what east and west are.
Did they at least know what hiking was?
They said they had never gone for a hike. I know. So here's the mathematical reality. It's pretty interesting. Now you can vary p also. So along the horizontal axis, I'm taking different values of p. So we're saying what's the probability a single student knows about this. On the vertical axis, it's about everyone knowing about it. And I have 3 different curves here based on whether you have a class size of 15, 50, or 200. You'll notice the class size of 15 doesn't decay that fast as you move right to left. So you're kind of saved in small classes. But as soon as you have 200 people, that curve goes down to the x-axis very quickly. Now, this has important implications as an instructor. If you care about equity and you want to put items on your exam that are fair to everybody, it means that you have to forcibly define everything in the problem, any term. Things you think everyone should know, you still have to define. So it's something to think about, this mathematical reality of what you're up against. It's tough. All right, you want to teach a big class? Lots of bodies? It takes a big room. Now what's interesting about a big room is you start asking people, what has to change in a big physical space? Now there are some things that are very apparent to people, and some that I've only discovered the hard way. So let's start with the things that were apparent. You better have some kind of voice amplification, and whenever a student says anything, you better restate what they just said, be it a question or an answer. These things are more apparent. So you better write bigger if you're going to write on the board. What's not so obvious is that your chalk needs to be thicker as the room gets longer, and they sell different thicknesses of chalk to deal with this. And if you're going to use computer graphics, like I do on these slides, you have to increase the width or font size or whatever the metric is, the weight of things. So when I first started teaching, I was using PowerPoint weights of 0.5, this left arrow, which even in this room is starting to be pathetic. But now I use the rightmost one, which on the screen in front of you when you're creating the slides looks obnoxiously thick, but in a big room is necessary. Another thing, laser pointers are only designed to work at certain distances, and the little green dot almost is invisible when you move beyond 100 feet. Furthermore, any Bluetooth connection you have starts to break down at a certain distance. So if you want to advance your slides and you want to walk around a huge room, your clicker is going to fail after a certain number of feet. Happens to me all the time now. You have to buy a better clicker and a better laser pointer. Now, what about what visually shows up? So big rooms wash away everything, is my experience. One of the things they wash away is color distinctions. Now, some of that has to do with projectors, if you're projecting things. But there's something about distinction that gets eroded through distance. Now, musicians will be familiar with this. If you need to do vibrato, which is the oscillation of the pitch around the true pitch, in a small room you can have a narrow vibrato. It doesn't need to be very wide. The amplitude can be small. But the same musician in a large space has to use a very wide vibrato. You can go read like the studies about this. The human ear just doesn't perceive the oscillation clearly when distance has the ability to erode the sound wave. Okay, the last thing, which is I think the most important one, is that large spaces eat up energy. And you have to give way more energy in those large spaces to achieve the same excitement level with students. So you have to find ways to bring more sparkle. Now, I'll show you some of the ways I brought more sparkle. I like to use a lot more images than I used to, and I now make a lot of animation videos. Here are 4 different examples that I've made over the last year for my classes. So, this is made using a language called MANIM, which stands for Mathematical Animation. It's a set of Python libraries that were created by Grant Sanderson, who you might know from 3 Blue, 1 Brown, the YouTube sensation. It takes a lot of time to learn something like this. It probably takes 4 or 5 hours to make a 1-hour video once you know what you're doing. So it's a huge time commitment. But the nice thing is that video seems to scale differently. It seems to hold its sparkle over distances in ways that just still images and speech do not. I don't know why that is, but that's my personal experience. I can see the back row light up when videos come into the lecture suddenly without any forewarning. So this is something I do. You can check out some links here if you want to start learning about this or see how I coded these. Now, another thing you learn in these videos is that, as I mentioned earlier, colors wash. So the bottom left and top right, I used a black background and then started putting color on top of them. Well, guess what? It looks awesome on your computer screen or within 20 feet, which is a lot of people in this room. But at 100 feet, you can barely see what's going on, shockingly. And so I had to switch to white backgrounds with colored stuff on top because it scales better. Something you learn. All right, here's the last lesson, our 5th. It has to do with emotion, interaction ratios, and large spaces. So this is a quote I like from a recent paper. It says, spaces aren't just about navigating. You don't just walk through them. They also come with emotional experiences attached. And so there's this emotional layer on top of a large lecture classroom. Now, if you don't think this is true, you can just think about 3 examples of houses, and you probably have different emotional responses to these 3 things I just put up here. Now, one thing that's fueling this emotion is what I call an interaction ratio. So in some settings in life, you operate 1-to-1. Some are 1-to-20, some are about 1-to-200. So the first thing I want to do here is I want to go to Socrative, and I want you to generate a list of settings. The goal is to think about settings that are 1-to-1. For example, tutor to tutee. So flood me with some ideas, also in chat, 1-to-1 settings. They don't have to be educational. If you've already thought of your setting, the harder challenge, what emotions or descriptive labels do you think about in that setting? How would you describe that setting? All right, we're going to start with chat. Mike, what do you got for us?
I got date from Blue, text message from Brendan Kelly, pair from Shani.
Okay, so we have a date, assuming 2 people are on the state, and we have a text message
Pair, which is pretty general.
and a pair. A
Interview.
pair of anything.
Yeah.
Ice dancers.
There was also duel to the death, apprenticeships, phone call,
Duel to the death.
tennis match, chess game, job training.
Chess match.
I don't know about job training.
Hi, we got some answers here. Date night, road trips, I like that one. Intimate dinner, dinner with my partner. Office hour, okay. Criminal parole officer. Okay, let's make it harder. Let's go to 1 to 200. I found this more difficult when I was thinking about it. Once you have your example, also try to think about the emotions you attach to that interaction ratio. Mike, we come to you. What do you got for us?
Okay, we got music concert,
Music concert,
town hall meeting,
town hall,
church,
church,
political speech,
political speech,
sports event, and bartender.
sports event, bartender. That's very exciting. Research talks, soloist concert. Okay, good. We got a lot of good stuff here. I'll show you what I came up with under the 1-to-1. Some of the things other people were mentioning. Pet to owner. By the time you get up to 1 to 20, coach to sports team or bachelorette to suitors. I found 1 to 200 the most difficult. Maybe it's not as common, or maybe I'm not as good as thinking about this, but this is where your large lecture class starts to show up. Movie theater goers was an important example for me. Now, when you say, how does it make you feel, or what do you emotionally expect in these interaction ratios, these were the words I put down. Deeply known, partnership, active engagement in the 1-to-1. Whereas the 1 to 200, now you feel anonymous, almost transactional. I'm paying you to come sit in here to experience whatever's about to happen. And passive. Now, I put this slide on here because I think it's important. When you start teaching large lecture classes, people have these emotional feelings around them based on the interaction ratio and the fact that they're in some huge space. So one thing I notice is, if I give the class a problem to work on, one of those your turn problems you saw earlier, there's a large percentage that simply just sit there and stare at the screen, that I have to walk around to and say, now is time to get active. Or I sometimes say, I can only help you if I can see what's going on in your brain, which requires you writing some things down. And there are a lot of people that it takes them 4 or 5 times of doing this over the quarter before they finally realize it's time for them to be active. And so I quickly realized I was trying to reprogram people and their expectations around the interaction ratio in the space we were in. And so it's something you have to face unless you want it to be anonymous, transactional, and passive, which is up to you. But that wasn't really my goal. Now, there are a lot of affordances, actually, of this interesting world called the large lecture classroom. I think the most important one is that you have the ability to generate quality, student-centered, large data sets. And you can even analyze those in real time. So let's try this with our 5th example here. This is the moment where I think tech is going to totally fall apart, but it'll be fine. So here's the goal. Looking at your phone, computer, however you interact, how many text threads have you been engaged with today? Send that number. If you're in chat, send that number also. We'll try to get your data into the data set. I didn't say how many people because you might have a text chain with like 42 people on it. That's why I said threads.
The numbers in chat range from 0 to 30, with most of them under 10.
Mike, I'm ready for your numbers.
That's
Can you just read off some, please?
6, 3, 3, 0, 6, 30.
Slow down, please.
Sorry. I didn't mean 30.
Okay, faster, please.
Okay, 6, 5, 5, 10, 15, 9, 8, and 9.
All right. We don't have an ultra-large data set. We only have 33 or 32 values here. So typically what I'll do in a stat class is I'll collect this data in real time, and then we will go and analyze it in real time. So let's just call this our texting data. Save it to a folder that we have no hope of getting back to. I think it's good for people to see data collection in real time. Often students have these really curated data sets, and they don't recognize that when the sample size starts getting large, you start getting all sorts of problems in your data. You already saw one if you were paying attention to what I just did. Some of the people in the room didn't complete the final question, and so there were blanks. So you saw me just filling in numbers in those spots, right? But other kinds of issues come up all the time. For example, what do you do with a data value that makes no sense? What if someone entered -4? What would you decide to do with that? What if someone had the number 75? So that's an interesting one. Well, I don't know where our data went, but we'll pull up this data set that looks like it's fine. Okay, this is pretty good. So one quarter I did this, and someone answered their texting question with the number 75. And so we had a good discussion in the room about what do you want to do with that? And we had come to a decision to delete it, that it was a mistake. And then as soon as we deleted it, the student raised their hand and said, "That's me. You deleted me." And I said, "Tell me about your number." And they said, "Well, I'm an RA in a dorm, and it's the first day of the quarter, so I texted everyone in my dorm, have a good quarter." So I really did do 75 data sets. So there are nice lessons that come out in these large lecture classes. Anyhow, once you have your data set, then you can go and display it in real time. You know, if you want to make a bar plot of our data here, we can go do that. And so then you get your picture, and then the students feel like, hey, I'm a part of that. I'm somewhere in that picture. And one of the nice things here is that your pictures tend to turn out beautifully. Whenever you're teaching a large lecture class, every histogram ever, if it's based on all the students, is beautiful. You don't have any crazy distributions. And this is actually really important. Let me show you an example of where distributions can be terrible. If you have a class of 15 and you ask every student to flip 7 coins and to report back the number of heads, you might get the histogram on the left. If you ask 200 people to do it, you'll get the histogram on the right. Now, the one on the left is clearly misleading. There are values in the support on the horizontal axis that just don't even show up. And you leave thinking that 4 is the most common result. But as you see on the right, 3 and 4 are tied because there's an even number of values in the support. It's binomial distribution. So that's one reason I love large lecture classes. The distributions are always pretty. Now, if you want to do some kind of statistical inference based on what's going on, that also turns out beautifully. Because you have such a large sample size, your confidence intervals are narrow and your hypothesis tests are high-powered. So it's exactly the kind of situation you would really like. And in fact, most data sets these days are very large because we collect so much data. But if you look at a lot of textbooks from the 80s and 90s, data sets had 10 or 15 data points, largely to facilitate doing painful things by hand with a calculator instead of a computer. Another interesting thing is that less common misconceptions start to show up in large data sets. So here's an example from Andrew Ng, who's a Stanford professor in machine learning. He runs one of the largest MOOCs, massive open online courses in the world. So it typically has 100,000 people in it. And one thing he noticed is if you have a misconception that only 1 out of 100 people make, it shows up 1,000 times in his class, in his data sets. And so you start to learn what the less common misconceptions are, which are hard if you're just a teacher teaching 50 students a year. It might take you 20 years or 10 years to see that the first time. And the next time it comes around, you don't see it as a common misconception. You just think, oh, this is an exotic error, even though it's just a rare misconception. Another thing you can do is, because you have a large class size, anytime you need some idea going to infinity, you can use the class size to help create that. So here's an example. You have some random variable x. Maybe it's the IQ of people in America. And you want to understand the average. So what do you normally do? You normally collect one sample of n people and take the average in your sample. Now there comes a point where you want to start thinking about the average as a random variable, a thing that has its own distribution. And this is a very hard moment in intro stats. From x being a random variable to x bar, the average being a random variable. Now, one way you can start to do this is by thinking about a second sample, which has its own average, and keep doing this a lot of times, m times, where m is big. Now, if you have m averages, you can dump them in a picture, and you can start to show students the histogram of x bar. Now, I think what's tough about this in a small class is this array of data, which is two-dimensional. It's very hard if one human being has to create both of these dimensions, if they have to collect the first sample, and then the same person has to collect the second sample, and so on. But if you have each student do one of the samples, the horizontal dimension is a single student, but then the vertical dimension of this is spread across different human beings. And so students start to feel like, oh, maybe something different could have happened for the average, because a different human being has a different number in the room. So if you have a large enough group of students, then n can be your students. Now another obvious one, and it was one of the reasons I first started teaching at UCSD, was the desire to have greater reach. And this is nothing more than the breadth versus depth trade-off. So when I was teaching at those small East Coast private schools, I said I was teaching 50 students a year, and that's very accurate. So over a 30-year career, you reach 1,500 students. Now, you have incredible depth with them. There were students that I taught for 3 years straight across multiple courses, computer science, BC calculus, and so on. They lived in my dorms. I taught them rock climbing. I'm still in touch with them today because of that great depth. But now at UCSD, where I teach 1,000 students a year, I'll reach 30,000 students during their career. So if you believe that what you have to offer in the classroom is really special, then seeking out large lecture classes is a way to bring that to more people. If you're willing to accept the breadth versus depth trade-off, which I understand that people aren't, because I've been on both extremes of this. Finally, there's a chance for everyone in the room to shine. So you could go calculate the probability at least one person knows about some exotic area that you plan to bring up. So let's start at the student level again. P is the probability a random student knows about your exotic topic that you're so excited about. What's the probability at least one knows? The best way to do this is to think about complementary probabilities. Figure out what's the probability no one knows and subtract it from 1. If no one knows it, then S1 doesn't know it, and S2 doesn't know it, and so on through all the students. And as you saw before, all those ands turn into products. And S1 not knowing it is just 1 minus P. So here we have 1 minus quantity, 1 minus P to the n. This is the reality that at least one person in the room can connect with your exotic thing you're about to do. So what does it look like for, say, P equals 1 over 50? That's pretty exotic in different class sizes. When you only have 15 people, there's not a great chance someone in the room can connect with it. But by the time you have 200 people, you're near 100%. Now, I use this to my advantage, not on exams. I don't want to have something that's so exotic no one's heard of it. I don't think that's fair. But if you're just doing an example in class, maybe you have the perfect setting for something. Maybe it's not an area that people are familiar with, but the chance someone in the room can connect with it and can offer feedback is very high in the large lecture class. You can see my exotic areas here. Age cutoffs in the Canadian educational system. There was a very important problem related to something Malcolm Gladwell did in Blink about that. Engine sizes and MPD ratings for cars. I had a student who could tell me that is not a linear relationship, that it has some curve to it. It was the only time in the entire class that that student spoke. But in that moment, he felt like I had connected to his lived experience. So I think if you have great settings that are really interesting and you want to pull people in, it's a chance to connect with students that otherwise wouldn't connect with you. So this brings us to an end. We have our lessons and we have our affordances. I hope this was fun for you, and I welcome any questions. Thank you.
We can take questions here from the group. Yeah, Stacey.
Can you maybe elaborate a little bit on how and maybe what you do when you discover those less common misconceptions?
Dave, could you turn on the audio on your screen? Oh, it's probably on.
Can I turn on the audio on my screen?
Yeah, you're probably fine.
Okay.
I think they
The
just-
question is, can I elaborate on what I do when I find a rare misconception? So it depends where it is and how to best address it. So sometimes what I do is I change something in the homework problem. So I'll put maybe a note on the homework problem that says, you might think this is how you should proceed. Here's why you shouldn't. There are other times that I want people to have it so I can have a discussion with them. There are other times that I'll put a note on the slides in red that's small, like you saw some of these notes today, and I may not address it directly, but I'll have it there for the people who encounter it. So it just varies. Yeah, it's a good question. Go ahead.
So I'm interested in the whole environment around the large lecture. So are there breakouts led by TAs? How does that relate to a large lecture?
Okay, the question is, what's the environment around large lecture classes? So at UCSD, the way we structure things is there's a lecture 3 times a week, which is just me in the room and no one else except the students. And then there's discussion, which is just the TAs and the students and no one else. That's the traditional. Now, in some of the lower level classes, take Calculus 1 maybe, what we do is we partner with the Teaching and Learning Commons. You have an equivalent idea here, right? And what happens there is they will embed some of their supplemental instruction leaders, maybe IAs is the name of different schools, into those discussions. And so the TAs and the SI leaders are together, but we separate lecture, we separate the human beings, basically, from faculty versus TAs and supplemental instructors.
I guess I'm wondering how would you like it to work? If you could model it yourself, are you happy with that? And, what's the relationship between you and the TAs?
What would I do if I could control the administrative structure? I don't have the answer to that. Sometimes I don't think about things until they are a possible reality, if I'm just being honest. Like I try to just say, what's in front of me, how do I maximize that? And I know right now, UCSD, like many schools, faces financial challenges. And so we just don't have the bandwidth to do some of the things people would dream about. So I haven't been dreaming much. That's the honest answer. Go ahead.
How often do you use the Socratic.com app in a typical lecture? You used it with us 5 times, I think.
Mm-hmm.
Is that typical, more or less, or?
Question, how often do I use Socrative in a typical class? If there are 25 lectures in a quarter, so take away exams and other exotica holidays, I tend to have probably 20 of the 25 classes have Socrative. In one of those classes that has it, I tend to use it once, but it will have 5 or 6 questions. So I won't go back and forth like I did today. And those questions will have a mixture of multiple choice and free response like you were doing, like you're effectively texting me. And I try to mix it up based on what's going on in the class. And if I'm going to have a data collection, it will come at the end of the Socratic questions, so we can then transition into a data analysis in real time. Go ahead.
I had a question about like how explicit you are about some of these like practices to your class. Like, do you tell them about like the perception of like interaction ratio, the fact that they might have like a different experience, so like the moves that you're going to use to hopefully get them out of that?
Hi, good question. So how often do I talk to my classes about the things that I just talked to you on the slides about? It varies based on, I do it more with the younger students because it's interesting for them. It's like a peek behind the curtain. If I say, I put this problem in here because that guy right there could have a moment to shine. Like I've said that in class before. But I also don't want it to get too meta because I just think I think my primary goal is to really try to do as deep mathematics as possible, and I tend to just get way too meta about this stuff and off track. So I've been trying to hold myself back. So I would say like 10 or 15% of what you've seen today, I will articulate. Now, sometimes it also depends on the class. So if I have a class that's getting very passive when I turn things over to them, then I'll come back and I'll say something like, here's what's going on right now, and here's what I'd love to see, because I want everyone in this room to get better. But there are classes for which I don't have to do that at all. Like an upper level class in mathematical statistics, everyone is ready to go and ready to do battle with the hardest things I can give them. So, good question. Go ahead.
2 questions in chat.
Let's do a chat question.
Okay, so yeah, I've got from Matt Anderson, can you say something about academic integrity, cheating in parentheses, in large classes?
Okay, what can I say about academic integrity? I almost had a slide about this. I decided to take it out. The thing I find with academic integrity is there's some percentage, I don't know what the number is, that will cheat in any setting. And then there's a percentage that will only start cheating when it's more opportunistic, when someone else has put something on the internet that they can read. And so my experience in large classes is, because they're so big, you'll have the initial set of people that will always cheat. And then that will propagate to the next level of cheaters, which will then propagate out to the next level. So I've had cases where 20% of my class cheated on a final exam, and all 20% were submitted to the Academic Integrity Office. I found that having discussions about what college is about and why we're doing what we're doing here to try to promote equity helps some, but there's some small percentage that I can't reach currently. And so I've had to adopt exhausting policies to deal and stop their propagation. So it means monitoring chegg.com and sending emails to the Academic Integrity Office every time something is uploaded from my classes to chegg.com, and they write to Chegg and get it taken down. But I'll tell you that this is now a losing battle for me, if I'm being honest. Chegg.com is only one of 20 different sites in 20 different languages. And I can only monitor a few of them between languages I speak and the TAs speak. So I'm currently trying to figure out new ways to deal with this. But the large lecture class creates the propagation effect, which is incredibly problematic. Let's take a question back here.
I'm sorry if I missed this at the beginning. Attendance. So one thing we've been noticing here, post-COVID especially, and this is sort of scattered data right now, right? There's no hard science on it, but students seem not to understand how important it is to be in class, especially those who spent formative high school years online entirely. And if you're trying to do active learning, right, then it's going to really impact how well they do in the class. So how do you manage attendance given the challenges? How do you incentivize it, or given challenges at scale? Is it worth it? Is it one of those exhausting labors that you just sort of surrender on? Help.
Okay, the question was about attendance in large lecture classes and how to make that go better.
Yeah.
This is something I've been thinking about that is incredibly complicated, to be honest. So currently what I do is I do not take attendance in lecture, and I podcast. The consequence of that is attendance rates tend to be between 30 and 60%. 60% is the number I get, the asymptotic level over as the weeks roll by, in a class that is more in the afternoon. 30% it would be an asymptotic rate for an 8 a.m. class that is podcast. Those numbers are pretty consistent across all instructors who don't take attendance at UCSD, and we too are experiencing the same decreases in attendance that San Diego State is. So, one thing I've started doing, and the same trend, it's even more dramatic in discussion. So, if you don't take attendance in discussion, you can get 0% attendance. You can get 1 out of 25, 2 out of 25. If the TA is amazing, they might get 10 or 12 out of 25. And this is true year after year. So I've started making attendance mandatory in discussion because logistically I know how to organize that. The discussion, the TAs can go collect the attendance and enter it into the computer system in real time. And in the future, I'm actually considering making attendance in lecture also mandatory. I don't have the system for doing that yet. That's something I'm going to think about this summer. But I agree with you that attendance is incredibly important, and we need to find ways to bring the students back to the classroom because I think COVID has instilled some bad habits. So thank you for that comment. I don't have the best solution, unfortunately.
Back in the olden days, one of the ways I dealt with that was to actually have something graded individually in class, and now that was on paper. And of course, the first time I did it, I heard 265 different sizes of paper being ripped out of class. Terrified me. But that really, and some of those points I counted, and some of those I didn't. And they didn't know which ones I would count, and I used those for replacement points for ones they missed, or lower scores for those people that came to all of them. They wanted to be able to replace too. So the first time I tried it, I found out that the university was over-enrolling in large lecture classes. There weren't enough seats in the classroom for everybody that was enrolled in the class because they started coming to class because they had good points. And some were group points, some were individual points. They could talk to each other, other different kinds. But it really did increase the attendance in class, and that was enough to help them understand that coming to class, to be able to talk to each other and share ideas was valuable. And so then it wasn't so much a stick as it was the carrot, that they got something from coming to class. If they don't get something from coming to class, then, you know, it's a stupid thing to do, but a waste of gas and babysitter fees and stuff. So you've got to recognize that it's a cost to them to come to class and make sure they're getting something from being there that they don't get from the podcast. So that was one of the ways, you know, ages ago that helped with that. But now with COVID, it's thrown a monkey wrench in all of that. I think it's a terrible challenge for us to try to overcome, because I'm not sure that can work as well now.
Yeah, thank you for that. So the idea that you were suggesting is try to actually give some graded things in class. You don't have to grade them all. Some can be individual, some can be group. I'll add a few things. I try to actually have a conversation with my students about why coming to class is actually different. And I talk about you have the ability to see my gestures in class, which don't show up on a screencast of what we did in class. You know, it's not a video camera looking at me, it's a screencast with my voice over the top. I also, when it's a your turn problem, I turn it over to the audience, I walk around and go and help people. And I say, here are the biggest weaknesses in your mathematical writing right now. And I individually try to visit 10 or 15 people every single time I do a problem. And I tell you, you're missing out on that chance to grow. And I also say you're missing out on the chance to build a connection with another human being. And you might want that human being to write you a letter of rec, and so on. So I try to actually have a conversation. But thanks for your idea. Let's go to the chat now.
Another chat, this is from Blue. Have you thought about assigning students to find an accountability check in partner classmate? I've done this informally for larger classes, but I didn't have them write it to me.
Okay, so the idea is to assign students into pairs. They're accountability buddies, basically. And then what do? They basically grade whether their partner made it?
I guess.
Something like that.
I can't. I read word for word. I don't know.
Yeah, that's a nice idea. I'll talk with Blue about that. Thank you for that idea, Blue.
One more from Colin if there's nobody else.
Yeah, we'll finish with Colin's question here.
Okay. In your experience, do the theoretical probabilities you discussed in this talk appear in real life? Ultra rare life moments, students not knowing common settings, etc.?
Yeah, so the question is, do the probabilities I said and the claims I made actually seem to pan out? Or are they just, you know, like a lot of these calculations depend on independence, for example, which may not be true. My experience is that they exactly pan out. When I put the numbers through, I said, that really matches my experience. And I said, you know, could I list 21 ultra rare events that happened this quarter? You know, and I got up to 11 or whatever 10 were on that slide, and those are just the ones that I was like, thought were okay to share in a public space. So I do think, actually, that the numbers are pretty close, which is kind of shocking. And just the amount of email I get and all these things, so yeah, it was a wake-up call for me to actually do the numbers behind this and see them match. Okay.
Great. Well, let's thank David again.